lots of sections to a graph, all right, we will do 2 and 3 sections or 4 and 6 sections to a graph, no more. Now, when we do hyperbolas, they have things called asymptotes. And in here, when I say there's an asymptote, your graph will approach the asymptote. That's what a graph does. It's like a boundary. Ours will never cross. Well, I can't say that. Most of the time will not cross. So like if I give you a graph, here's your XY coordinate system, and I say there's an asymptote here and here. Fair enough? Generally, ours will look like that. Okay? And there'll be one down here. That's not true for all of them. It's like when you get to college and you have an asymptote and you don't say your high school math teacher told you they never cross the asymptotes. That's not true. Some of them approach the asymptotes but cross. They go over the top, come back down, and then approach. Will we have any like that? No, we will not. But is it possible? Yes. So just realize that can happen, and here it will not. Ours will only approach, and they will cross if it's crossing in one section in the middle. So like if there's a 6th section. Now when you're doing this, there's 2 types they're going to show you. One is where it's already worked out for you nice and pretty. The first one. Usually I don't even teach this one, but it has a tendency to show up on college entrance exams. It doesn't show up on the ACT very often, like never that I know of. But on a college entrance, it may. So you need to see it so you recognize it. All right. Then we're going to show you the real ones that actually happen. You will get a lot. All right. But I want you to know this one here so you pass these things. When you go through it here, you remember A, H, and K from our other, you just had a test over them? So if I gave you y equals A times X minus H quantity, some exponent, right? We'll put a 2 there just for fun. Plus K. What did the A do? Yeah, it's your stretch, right? Compression. If it's negative, it did what? No, negative, no. Fractions compressed it. Whole numbers stretched it. Negatives flipped it, right? Fluffed it. Okay, what's the H? X move. Or the X part of your vertex is squared. And the K is the Y move. All right. None of that changes. All right. And remember, it's always opposite of H. This is the same thing. It's just in different spots. And now instead of the H and K being a vertex, they're asymptotes. The A is still a stretch, still a reflection. So far? Mm-hmm. All right, so when you look at this here, this is a parent graph, y equals 1 over x. This is one I don't think you probably know. It should be a newer one. When you look at this, this is really like writing 1 over x minus 0, because there's nothing attached with this 0, and there's no y, is what it's like. So that's what you're thinking in your mind. Okay, the zeros represent asymptotes. It's the boundaries of your graph, where your graph divides in half. So like here, x minus 0, opposite sign, doesn't really matter because it's 0, but you have an asymptote at 0. So there's truly a dotted line there that divides that graph into half, top and bottom. Good so far? Okay, the K, or the Y one, is your vertical asymptote, and this one's also 0. So there's another line here that divides your graph into left and right. Now, your graph has to show up on here. They're always functions for us, which means they can show up opposite each other like they do here. They can show up across from each other. Can they show up top and bottom? No, because that's not a function. So if you have one top and bottom, you've done something wrong. Fair enough? All right, now, to actually figure out how to graph, we're doing just sketches in here, nothing real elaborate. So this here line is x equals 0, divides it into your left and your right. I just need to know if it's top and bottom on the left and right. So you plug in one number on either side. I always do the number closest to because it's the smallest, and it gives you the easiest number to work with. So I'm going to plug in -1 and 1 to your original problem. So I'm going to plug in -1 for x and find out what y is. Good so far? All right, so when we go over here, you're on your original. So I'm going to say y equals 1 over, plugging in the -1 for the x. Good? So y equals -1. So this point, -1 for the x, because that's what I plugged in, -1 for my answer. Understood? So you graph that point. Go to -1, 1, right there. Now, asymptotes are boundaries like fences. So you have to approach the fence, but you can't go across the fence. So here, I start here, and I approach my top asymptote. I just draw up as close as I can get without touching. And I approach my side asymptote. That section of my graph is now done. Questions? What's the matter, Aaron? Have a look that you don't like something.
No, it's just the bag's different.
Just the way that's going today. Okay, what's the next number I'm going to plug in? 1. So now you're going to do y equals 1 over 1, which is 1. So your point, you plugged in 1 for x, you got 1 for y. Good? Go to 1, 1, put your dot, approach your asymptotes. Graph is now done.
Where do you get all the ones from?
Where did I get all the ones? Which one?
Oh.
There's a lot of them. Okay, this is the original, right? Y equals 1x. You go over here, x equals 0. Good. 1 point to the left and to the right. So I have a -1 because that's to the left, right?
Why do you do that?
And because our eyes go 1. You can use any number.
So
You can use -2, -3, -4, anything that's on this side of the graph.
And it'll always be a point on that asymptote?
Yes, it'll be a point on that graph. All right, which tells you how to approach the asymptote. Okay? So if you wanted -2, you can do that. -3, anything over here would work. I just choose the easiest ones. Good? So now I take a -1, I plug it into my original. So that's 1 over -1. Good? Equals -1. I plugged in -1 for x, so that's where that came from. I got -1 for y. -1, -1, plot your point, approach asymptotes. That help?
So will it be like that like every time?
What do you mean? Like, yes.
So it'll always
Well, it will not always be -1, 1, because your asymptotes are going to change. But it's always 1 to the left and 1 to the right.
So it's always going to be smaller than 1. Because whatever number you put under 1, or like y equals 1 over what a number, that'd be like 1.
It's not always 1 on the top. They happen to be 1 here. It could be any number on the top. It could be 5, it could be 3, it could be a negative number. In this situation, yes. Okay, are we good? All right. Can I go? Yes?
This big.
All right. Now, that's because this one here is already in the form for you, so there's no work required to find your asymptotes. You just have to work. So when you go here, you look at the h and the k. So if I look here, x minus h, so this is an x move, right? Because it's attached with the x. So I know that x is going to be what kind of line? X equals a horizontal or a vertical? Horizontal line. So this is my horizontal asymptote. Always opposite sign, like before. Nothing's changed. So did I just say that backwards? I think I did. Vertical asymptote?
Yeah.
Okay, vertical asymptote is 4. Because it's going up and down. I did it in my last class too. I gotta use different words. Go. So vertical is your x, horizontal is your y, and your y is just the number as is. So what's my horizontal asymptote? 6. Is everybody with me? So x gives you vertical, y gives you horizontal, or HK. What?
So it's not -4.
That's always opposite sign.
Yeah.
So if it was +4 in there, then it'd be -4. Good? Because you're setting it equal to 0, technically.
Wouldn't 6 be negative?
Nope, that one's not attached with the variable, so it's as is.
Oh, so those show you were get drawn as dotted.
Yes.
Okay.
So this says I go to 4 on the x, and I draw my asymptote, vertical. Then I go to 6 on the y, and draw my horizontal. Is everybody there? Gives you your x and your y. Okay, now I've divided it into my sections. This is x equals 4. So what numbers am I going to plug in this time?
Well,
3
4
and
and
5.
-4. No.
3 and 5. One to the left, one to the right. Of
Oh.
4.
The X, not the Y.
Not the Y. The Y, we could care less. We do left and right of the X, and then that will give me top and bottom of the Y.
Wait,
Go ahead.
when did? No.
What?
It's always gonna give us that number.
Yes. These two always give you your,
But each one's on the opposite side of the Y.
what?
3 and 5, they're on opposite sides of the Y.
It has to be
The
out.
X.
No,
This is the X equals 4 line.
of the what?
That's the Y.
But
That's
what?
the Y.
No.
Yes.
It goes up and down like a y-axis, but it's X equals 4 line.
But
Just like your y-axis here is X equals 0, is it not?
Sure.
Yes.
But
No buts.
that's the Y. The Y goes from top to bottom, and the X goes from left to right.
Yeah.
The Y and X axis is.
The y and x axis do, but not a line. X equals 4 goes up and down.
X equals 4.
Goes up and down on the Y axis.
No, up and down on the x-axis parallel to the y. Anyway, here we go. So you're plugging in x equals 3, x equals 5. So you're plugging in 3 right here for your x. This is where you're at. So you have y equals 1 over 3 minus 4 plus 6. 3 minus 4 is, so this whole thing is -1. So -1 plus 6 is 5. So your point is 3, you plugged in 3, comma, 5. So you go to 3, 5, put your
Wait, what?
dot.
Oh, I see.
It's a point on an x, y coordinate system. Is everybody there?
You always just do one.
Because we're
one
sketchy.
to the left and one to the right.
One to the left, one to the right.
Is it always going to be the easiest?
Yes. Okay, so now you take this guy, and I approach my asymptote, and I approach this asymptote, and I'm done graphing him. Okay, now I have to do the other side. So now I'm going to plug in what number? Probably 5. So now we do y equals 1 over 5 minus 4 plus 6. 5 minus 4 is
1.
1. 1 divided by 1 is
One.
1. Answer is 7. So my point is 5 comma 7. So you go to 5, 7, put your dot.
It's the turning point every time.
It is. Well,
I feel
So
like
we don't even have
it's
to show the word.
what?
yeah, we have to show a word. That was a weird.
Yeah, they're not gonna give us that, like, the real,
Oh, you don't, none of this is on here. I'm showing you how that came.
except for the dotted line.
Not even the dotted line.
Oh.
You have a blank graph.
But can we do the dotted line without getting?
You have to do the dotted line.
Well,
So then how do you do the
I'm
regular?
confused.
That's how, that's what the points do. You pick a point,
What do we have to do?
graph it in. Everything I
So
just did.
you hand graph.
Oh no!
Very good.
How long is this assignment?
All right, here we go. Let's look at this one. Okay, -3, x plus 2 minus 1. What is my vertical asymptote? -2. What's my horizontal asymptote? -1. So now you go down to your graph, and you graph -2, -1. Which one was which again?
The vertical is -2 and the
Negative
horizontal
two.
is -1.
So we go to -2,
Oh, that's easy.
graph. -1, asymptotes. Okay, I've got my graph device.
I'm not ready.
That's easy.
So first step, asymptotes, graph. Well, dotted means it's not part of your graph. Straight line means it is part of your graph. Are they technically part of your graph?
Yes.
Yes, ma'am.
They're hard to see. I don't care. I won't throw a fit. Well, maybe a little bit. Okay, now we've got our asymptotes, right? And this is x equals -2.
So you need.
Okay, what points am I going to plug in?
-3, -0.
-3,
Negative.
No, not -2. -2 is the line.
-3, 0.
-3, -1. You could use 0. It would work fine. Really? The ones to the right and the left usually give you 1 in your problem.
Nope.
All right.
Nope.
Sketch reflection. Okay, here we go.
Nope.
Ah,
You can do.
go away. I don't know. All right, so now we have to plug in -3 and -1 into my original problem. This thing hates me today. What's my original problem? So I don't have to go back up there.
-3 over x plus 2 minus 1.
It's 2.
-3 over x plus 2 minus 1.
Correct.
Okay, we're plugging in -3 right here. So -3 plus 2, -1, -3 divided by -1,
3.
3 minus 1,
2.
2. So when I plugged in -3, I got 2. -3, 2. Put a dot.
Wait, why are you going off the X? No.
Because if
Why
you
am I
leave it
graphing a point?
-3 over x.
So what about those dotted lines right where they?
This tells me how I graph it, not how you. This is how I'm sketching my my hyperbola now.
We
Okay.
never use this line, the horizontal line, to plug in the pieces.
I'm gonna plug in the points now. We use a horizontal to graph now. All right, now let me show you where the biggest mistakes come. You guys like this x and y axis, and then this is going to be wrong, so don't graph this. You take this thing and you say, hey, I'm going to approach my asymptote. Correct. And then you approach this asymptote, but you approach the x-axis. Is that my asymptote? No, that is not right. Where am I approaching? The -1. So this has to go past the x and approach your asymptote.
Wait, somebody.
What?
So you don't go like. You go.
It's a gradual curve.
So it's like.
It's not an L.
It doesn't have to be
It's
like
like a banana.
close to it. It can be like next to it.
I'm not real grumpy. That's what you're asking me. The only part I'm grumpy about is if you cross the axis or not. That part makes me grumpy.
I just ripped my paper.
Okay, so now you plug in -1. Okay, is everybody got -3 all right? Okay, so now we're plugging in -1. So -3 over -1 plus 2 minus 1. Does everybody understand now why I pick 1 to the left and to the right?
Nope.
Yeah. I see.
Yeah, you get 1s here. 1s are real easy to do math with. Okay, -3 over 1 is -3. -3 minus 1, -4. So this point is -1, -4. So now I go to -1, -4, and I put my dot. Now you have to approach the asymptote. So this guy is going to approach this one, and then you approach the one to the side. And that is now graphed.
Flip over the dotted
No.
lines.
Most of the time, but not always. Sometimes they will be side by side.
I thought I discovered something.
Yours might always be flipped. I don't know how hard they make them. We'll have to check.
I hope they're
Okay.
not really hard.
Do I have questions before I let you go? Go.
Jim's wasn't it on the second where it says identify the reflection.
Oh, did I did. It is. Stretch of reflection is -3, isn't it?
Yeah.
So if you notice how our first ones were in the first quadrant and the third quadrant, these are here on the second and the fourth because it was negative, so it's flipped where it was.
Really?
So when they're really simple hyperbolas, they'll always be opposite each other.
Wait, how'd you know it was -3?
Because on the top here, this is a -3 over something, that's your stretch and your reflection. So if you look, when we graph, usually the other one is 1, 1, right? Oh, this one here's down 3. He's down 3 from the top,
I'm kind of confused.
okay? We don't do these very often, so. Okay, your turn.
Community asked.
4 to 2.
All right, watch this, because it helps you understand when your graph is right and wrong.
Cost the bus to your boy.
Yeah, I know. I messed up. Alright?
This is a mistake I wanted you to see.
You want 2 and 2 instead of a positive 3.
Yeah, he used the top number. Watch what happened when he plugged in his points. So the first one worked all right for him.
That looks like
Now-
not a graduate.
When he plugs in 3, watch what he gets.
Okay, so then.
Okay, what happened right there? What's 3 minus 3? 0. And can you divide it by 0? No, that's undefined. What is that telling you? No, it tells you you're on your asymptote. Because the asymptote never has an option. So when you get something like that, there's something wrong. Alright? It's a good thing to check.
Yeah.
What?
Learn from you, right?
Don't want to see that mistake again, Costin.
You want me to keep going? Or am I done?
No, keep going, keep going.
What is that? Good job.
That looks like your face.
Oh, that's what it is, that's true.
That's on camera too.
Really?
That's your face.
Alright, does everyone understand?
Nope.
Yes.
Alright, so what was your true asymptote?
28.
That's right next, guys.
The true asymptote was not 2, but 3. So you go to 3, and when you plugged in 2, what did you get? 2, right? So that guy went through there. When you plugged in 4, 6. Done. Alright?
Nope.
Okay, next one. This is how they're really going to look.
This is hard.
Not yet. Okay, this here's already done for you. This graph actually started out like this. X plus 1 on the top, x squared plus x minus 6 on the bottom. That's how they're going to look. Now from here, we have to find the vertical, the horizontal, and I won't make you do stretches. Just vertical and horizontal is what we're going to look for. When you do this, first step, I don't like this first step. My first step I do horizontal, but I'm going to show you vertical first so you understand. You take and you factor everything. So the factors of 6, and they're always going to be fairly easy right now because we're not testing factor, we're testing asymptotes, right? So factors of 6 that subtract to 1 are 2 and 3. Everybody good? All right. To find your asymptotes, you set the denominators equal to 0. So x minus 2, x plus 3 equal to 0. So my asymptotes are x equals 2 and x equals negative 3. So if I went to go graph this so far, I'd have an asymptote here and an asymptote here. So now instead of 4 sections to my graph, I have
3.
Well, there's going to be 6 because I'm going to put a horizontal in there in a little bit. All right. So that one has 2 vertical. Okay, find your 2 vertical. Just tell me what they are. That's all I want to know. Got them? Negative 5 and 1. So these 2 vertical are negative 5 and 1. Good so far. All right. Now, to find the horizontal, you set them both equal to 0. Okay. All right. Now, horizontal has 3 cases. We're going to do 2 of them quickly, and then we're not going to do the third one until after we get the first 2 done. All right. Now, horizontal, and we're going to cheat. There's this great big long thing you can do with a ton of math. And when you go to college, your college algebra teacher will teach you that great big long thing. During that part, you can sleep and do this cheat and never ever tell them. All right, that's what my daughter does. It works every
I
time.
have a question.
Okay,
I have a question.
what do you do?
I have a question. When you taught, did you teach him that thing, or were you just
I
like,
taught him the cheat.
yeah, because you're just like, I'm too lazy.
Yeah, exactly. Why do that stuff when you don't need to? Sometimes math teachers like to do math just because they can.
Or because they like it.
And yeah, I'm not quite that way.
Creative.
I like the easy way. All right, this is the cheat. What it's called for your horizontal asymptote is the most important over the most important. And when they say most important, when you look at the numerator, it's the term with the highest degree. And the same with the denominator. So you're looking at the highest degree term. All right? And you ignore everything else. So when you go up here, on the top it's 2x because that's all I have. On the bottom, what's more important, the x or the -3?
X.
X, so I ignore him. He's just gone.
Really?
Yep, do not like him. For the horizontal,
Same
not
thing.
the vertical. All right, so now for my horizontal, I have 2x over x. Does that reduce?
Yeah.
It does, because the x's cancel. My horizontal asymptote is 2. That's the exact same answer you get when you do the long step.
Show us the long stuff. Show us the
No.
No.
All right, so there are 3 options for horizontal. This is when the x's cancel. When the x's cancel, so they're the same exponent, you get a number. So you get a very pretty line. First option. Second option is when the denominator is larger than the numerator. So when you go here, what's my most important on the top? 2x. Don't care about him. Who's the most important on the bottom?
X squared.
X squared. Don't care about those guys. Now, when we do this and I reduce it, I'm left with an x on the bottom, right? Or in the denominator. So that's 2 over x. It doesn't matter if there's an x squared, x cubed, whatever. If there's an x left in the denominator, the answer is 0. Do you know why?
Because it's 0 because you said it's 0.
Yeah, but
So
why?
therefore it's
There's
0.
logic here. I didn't just make that up.
'Cause you're
What
not
happens
God.
to that fraction as x gets big?
Well, you
So
can-
let's say x is 10.
5.
It's 1/5. So if x is 100,
0.
it's 1 over 50. If x is 1,000,000, what am I approaching?
0.
0. Anytime there's an x in the denominator, that fraction approaches 0. So your asymptote is 0. That's why. Everybody good?
Just give me a 0.
Okay, so we have cancel, straight number, easy. X left in the denominator, 0, easy. The third one is when the x's in the numerator are larger than the denominator. So this would have something like when we got done, we'd have like 2x cubed over x, something like that, or x squared. Does that make sense? So this guy is larger. So that reduces to 2x, right? Okay, it's no longer a beautiful horizontal asymptote. It's a slant. It's actually a line with a slope. So those we're going to do last because they take some work.
Oh no.
Okay, so we're going to do the first 2. And then we'll do the last. Okay, when you look at this one, just examples to make sure we are clear. Are you with me? We have x squared over x. Okay, the numerator is larger than the denominator, so it's a slant. I'll show you how to do it later, but when you do this, this asymptote actually looks like that.
Why?
All right, I will show you later. Okay, next one. We have 3 over x squared. All right? The x is in the denominator, so it is 0. This horizontal is 0. It's right there. Good? So, x in the numerator, have work to do you don't know yet. X in the denominator, 0. Next one, we have 2x over x. So the x's cancel, giving you a straight number at 2. All right, are we good? 3 cases. Cancel, straight number. X in the denominator, 0. X left in the numerator, half one. Good? Okay. Now let's look here. All right, I put them in the order I do. Okay, you can flip 1 and 2. Steps 1 and 2 can be done in any order, doesn't matter. I always do horizontal first because I want to do that before I factor, because I need the most important over most important, which is already set up for me. Fair enough? So that's why I do that. So when you look here, what do I care about in the numerator? X squared. These guys are gone. Okay, what do I care about in the denominator? X squared. X squared divided by x squared is 1. So you go to your graph and you graph your horizontal at 1. Where's it at?
You don't have
So you're down here, horizontal, 1. Okay, everybody good? Horizontal's done. Now we have to do the vertical. So we go back. Yes, x squared minus 4 is a difference of squares, right? We have to factor both to look for a hole in the graph. All right, so if they cancel, so I factor the top. So factors of negative 12 that give me 1 are 4 and negative 3. Everybody get the simple factoring? Okay. Difference of squares. So that's x plus. What's x squared minus 4? What's the factoring? X plus 2, x minus 2. So these are the factored form of above. Do I have anything to say that will cancel? No. So I have to use it as is. Now I have 2 left on the bottom, which means I have 2 vertical. You said x plus 2 and x minus 2 equal to 0. So I have negative 2 and 2 for my verticals. Everybody ready? Okay, so go back to your graph. Put in negative 2 and 2. All right, now I have 6 sections. I have to figure out where my graph is. The point that's tricky. Okay, over here on your left side, it's either going to be top or bottom. Fair enough? So you've got your asymptote, your asymptote, your asymptote. This guy's either going to be up here or down here, one or the other, right? Don't know which, but we know it's one. So I need 1 point to figure him out. The same is true on the right side of the graph. It's either going to be top or bottom. 1 point to figure it out. The middle can be multiple things. Go ahead.
If the one on the way left is top, the one on the way right can be top too.
It can also be bottom.
But
Okay,
in
the one in the middle, what?
but in a regular one, it would just be like you can't have them right next to each other.
You can have them next to each other. You can have them up and, like I cannot have one here and one here. They can't be on top of each other
Oh, okay.
because then they're not up
But
to
they
each
can
other.
be left and right.
They can be left and right. All right, the middle can be a couple of different things. It can be a parabola. So it cannot touch this guy and look like this. It could be a parabola facing down. Or, this is the one time in here, it will cross the asymptote. It could look like that. So your middle,
You never have that.
in here, this one you will. You won't have the ones that go, you will never have the ones that do this. These you might have. All right. So in order to graph that, how many points am I going to need? No, only 2. I either need to know if they're both up, both down, or one either or. So I need 2 points to graph that middle, because I don't care where the vertex is. Fair enough? So on this, what points do I need to plug in? It's just like before. So if this is x equals negative 2,
So
negative 3, and negative 1. This is x equals 2, so what do I want to use? 1 and 3. So you're plugging those 4 points in just like before, except instead of 2, you have to plug in 4. Good? So you plug negative 3 into your original. I have a table up here. I usually don't use a table, but you're welcome to. So you plug in negative 3 to your original problem. Everybody understand? Put it on the calculator, get your answer. Negative 3 gives you negative 1.2. Good? So you go to negative 3, negative 1.2, right here. Can I graph that? Can I graph that side? Yeah, because I know what that one looks like now, right? So I approach my asymptote, and he's done. Now I need to do the middle two. So next you plug in negative 1. Okay, when you plug in negative 1, what do you get? 3.3. 3.4? So right here?
No, 4.
4?
Yes.
Okay, negative 1 is 4. All right? So now I either know I have a U facing up or an S starting positive ending negative. Okay, so I need to know what 1 is. What's 1?
That's 3.3.
That one's 3.3? Okay, so they're both on the top, so what do I have?
Yeah, that little squiggly line.
Nope, not a squiggly line because it doesn't go down.
You.
I have a parabola, a U.
I know where the verse.
Seriously?
You don't, and we don't care.
Wait, that can still be nice on the squiggly lines, can it?
No, it doesn't go under.
Oh, so it has to go under.
It has to, one has to be above, one has to be below.
Oh,
If I don't have above, below, it's either a U on the top or a U underneath.
Okay.
Okay, now when you're looking at this, I don't care where it's exact. Some things they do that are kind of mean. They'll put them really close so there's only one number in between. If they do that, you have to use fractions to figure it out. Like you might have to use halves or fourths or something. But you always got to check 2 points. Good? Okay, next one. So when you plug in 3, what do we get? 3 was 0. And sketch it in. Good? Your turn. So most of you did the horizontal, most important over most important. What's the vertical? What does it factor into, Aaron?
Well, you use a lot of
Yep.
stuff. Well, it's then it's 5 and negative, or 5.6.
X and
X minus 5.
X minus 1, right? Does anything cancel? So nothing cancels, so I have 2 vertical. So my 2 vertical are what?
5 and 1.
X equals 5 and X equals 1.
Wait.
Go ahead.